Hello again, everyone. I wasn't a huge fan of how, I should switch over here. Yes, I wasn't a huge fan of how the iterator class was handled in previous terms. I just didn't like some of my examples. And so I wanted to go over some of the code, and I made a brand new example as well for this, for the iterator class. The idea behind an iterator class is, let's say we have a linked list or a tree or name a data structure essentially. If I want to be able to traverse through this data structure without knowing how it's actually put together, I don't want to know how it's built. I don't want to know how things are stored. I don't want to know anything about the data structure itself. I just want to be able to use it. If I want this as some sort of grab bag, throw stuff in it, like we're going to do with standard template library, I need an iterator. The iterator allows me to walk down or traverse my data structure without knowing how things are built. And again, it's essentially pointing to where I am currently located. I can get the next, I can get the previous, maybe I can get some other options as well, but I don't exactly know how it's all put together. And I'm going to demonstrate this with code, hopefully, relatively well. Now the code is already written just because I know I've tried to give the demo before and sometimes there's little nuances in the way. So I have overdone the code. There's way more functions that I actually need to actually demonstrate this idea, but I wanted to show a more complete example. So not ending my slideshow very well. Let me plop up the code here and have a look at it. So first of all, I want to just make sure everything's recording. Fine, just in case. Okay, here is what was the linked list class when we made the same code I used for doubly linked list, but I've removed doubly linked list to simplify things. I've removed a lot of stuff. I essentially have iterator, linked list node, linked list node, and then I have two other things here that I'm not going to deal with right now. And I have a generic demo iterator, just to show you an abstract class. And here's my main method that I had before. Let's go over what the main method is going to do. I'm going to have a linked list. I'm going to add a bunch of stuff to it. I'm going to do one other thing after I've added a whole bunch of stuff to the front and the back and I printed it out like I've done in the past. I'm going to try and use my iterator. So I'm going to get the start on my linked list. What's the start? I don't know. It just gives me some kind of iterator. It's a linked list iterator, LL iterator. And an LL iterator is just a kind of iterator. I actually have a generic version of it right here. Here is the generic blueprint for this kind of function. It has a next, it has a test for has it next, and it can check to see if two iterators are equal. Now I'm using using a pointer here just to get it more general, but essentially I'm checking to see if two iterators are equal to one another. Those are my big things. Oh, I also need to be able to get the value at that particular iterator, the thing that's stored there. But beyond that, I don't care how things are built. So I can get the next one. So I go next. I can check to see if there is a next element, and I can get the value at a particular position. And I can check to see if the iterator where I am right now is equal to some other iterator. And we'll see why in a second. Okay, so here's my main method again. I'm going to make an iterator. I'm going to output a test. I'm going to get the value for that iterator at that position, at the starting position, and output something. Then I'm going to keep checking, is there another element? Has next? Does it? I don't know. Does it have another element? If so, get the next one, move it one position over. Essentially just keep on moving my iterator one position over, the next element in my linked list, get the value, print it out. Okay, let's run this. Hopefully it's going to work. There it is. Okay, here's my iterator printout right here. Same thing as I had before, but instead of calling print in my linked list, I'm actually getting the next element, printing out the value, getting the next element, printing out the value, doing that over and over again. So it should exactly match this thing up here. This is me using the print function for my linked list, which is nice. But if I want to get the third element of my linked list, I can do that with an iterator. I can get the start element and go next three positions over. And I can technically walk down my entire linked list with just the iterator without knowing how a linked list is built. My linked list iterator class looks like this. So let me put things, so let me leave it like this. It has a next, I can get the next. It has a test to see if there is a next. I check to see if two things are equal, and I can get the value. Notice all it is a pointer to the current node. So wherever I am, that's my iterator position. My linked list class, I've added a couple extra functions in here. I have a find, so I can find this item of data, this value, in my linked list and return the iterator for it. These are just generic kind of functions you might want for a linked list. Maybe I want to insert immediately after a particular position. Well, I don't want to say this particular node, because then someone has to know how this thing is built. I say, no, or immediately behind this iterator, whatever the iterator whatever this iterator is, just insert the next element in my linked list immediately behind it. Maybe I want to remove the element being pointed to by the iterator. Maybe I want to get the particular iterator at a particular index. Maybe these are the big ones I need. I need to be able to get the start and get the end of my linked list. So this is the actual function I'm calling for my testing my code. And I have a couple little quirky things that I'm working around here. So here is here are a couple extra functions I didn't have before. I can get the start node, get the end node. I had those before, but notice they were protected. I didn't want anyone to know that I was returning a linked list node. So now I can just say return the iterator. Everyone can know I have an iterator. You don't know how my data structure is built. You just know I'm pointing over there. Okay, here is inserting at the front. So if I want to insert at the front, a particular node at the front, oh, we already had that one before. Set the start pointer, I thought it wasn't new. Get the iterator node. Oh, that's my new function that I added. Essentially, I want to be able to find a particular position. If you give me an iterator, tell me the linked list node associated with it. The iterator node doesn't let me access the node even. It just tells me the data. I can't actually drill into the node. So I need another way around it, which is me walking down my linked list until I find the iterator that I'm looking for, stopping there. Here's the big part of all this, and I can do this all day talking about linked lists and iterators and all this kind of stuff. So here is, let me see here. If I'm going to remove a particular element add a particular iterator, I'm getting the particular iterator. Give me the iterator, I find a linked list node associated with it, the thing the iterator is pointing to, and then I see, oh, can I remove it? Is it at the start? If it is at the start, then the new start is whatever the next element was, so I'm removing the first element. Otherwise, I'm going to find where this thing is, I'm going to get the element before it, so that I can hook up the previous to the next. Essentially, I remove the middle point. So the thing I'm trying to remove, I need to remove. If I'm removing the middle element between two other elements, I need to find the previous element, the next element, and then hook those up instead. All little quirks that you can play around with, and you can look at the code. I want to see how things are working with this, so let's see. The size of my array, that's nothing new. Get at a particular index, I can do that, that's fine. Oh, get the iterator at a particular index, fine, right? Now I have access to the position in my linked list, not just the data, the actual position where I'm aiming this thing. Maybe, let me see here, remove from the back, insert at the front. Let me see if there's other things I wanted to make sure we went over. No, I think that's everything. Okay, so I've already showed you this, right? I said it's working the same way as previously. I'm going one step over, one step over, one step over. Okay, I'm manually getting the next element in my linked list. Here's why I wanted to show all of this. and you can look at all this linked list code and how it's using an iterator as an example. The iterator does not know anything about how a linked list is built. The iterator class has to know what a linked list node is, but if you get one of these iterators, you still have no idea how this linked list class is built. You just know you can get the previous and the next, and whatever the case is. So the person using this linked list does not know anything about how things are put together. They get access to an iterator, which they can see, what functions they have available to them. They get access to the linked list itself. That's all, right? You don't know how things are put together. And by the way, the iterator is a public, it's an instance, it's a subclass of the abstract class demo iterator. Demo iterator just says, yeah, you need to fill in these functions, right? You need to make these functions for this thing to work. I also have another iterator here called SA iterator. SA stands for secret array. The reason it's a secret array iterator is because here's what secret array looks like. Secret array has an array. It has how many elements I've stored. And I'm inserting and removing at particular indexes in my array. It's just an array. There's nothing special about this thing. It's just an array. But I don't need to know. It's called secret array because I'm not supposed to know that I'm using an array. I'm going to pretend it's acting like a linked list. So I can get the next. I can insert elements at a particular position. I get the start. I can get the end. But it's still an array. There's no linking or anything. It's just an array of data. Of these LL data items. So it's just an array. But I'm hiding all of that stuff. I have inserted front, inserted back. I have the exact same functions I had before. Insert after, I'm going to look into that. It doesn't seem to be found. I have the exact same functions I had before. The only difference is that I'm using an array now instead of a linked list. But the name of all my functions, this, all my public functions, even the plus operator, all of these functions are exactly the same as they were before. There is no difference. So if I gave you this secret array data structure and this linked list data structure, and I told you to use them, you'd use them the exact same way. Nothing would change. They're effectively identical. Under the hood, they're completely and radically different from one another. This one has an array, the other one has a string together, a bunch of pointers. One points to the next, to the next, to the next. But to the user of this thing, you don't know, you're not supposed to know how it's built. And so my iterator for the secret array, I have a different kind of constructor for the iterator. When I make an iterator of a particular type, I have to pass in the pointer to the array, the current position, the maximum number of elements, and I can get the next and the next. I can see if there is a next, but it's still just an array. It's pointing to where I am in the array. It actually keeps around the index where I am in the array. It looks, acts, behaves exactly the same as my linked list iterator. The reason I can say this with such confidence is because of this. Let me make sure I'm doing that right. Boom, boom. Nope, my keyboard is unplugged. Let's do this. And now, it is no longer using a linked list at all. It's using a secret array. My data structure, instead of it being a linked list iterator, it is now a secret array iterator. No other code has changed whatsoever. In fact, I could make it even more obscure than that, and not even do that. Just ask for the front, have a generic demo iterator data structure, and go with that. But the pointer stuff got a little wonky. Ideally what I want is it just says it's a demo iterator. I don't even know what kind of iterator I have. It's just some kind of iterator. Okay. Hopefully it's going to work. Oh, there we go. That weird bug that we have in Visual Studio. Here it is, iterator printout. The exact same code as I had before. I've changed how this thing is printing off because the secret array printout method I had, I just changed what the print function does. That's why these look a little weird. That's why they have an S in front of them. But this thing right here hasn't changed at all. Input stuff is going in the same as it did before. Stuff is being removed same as it did before. But now it's using an array rather than a linked list. And no one needs to know. That's the reason I wanted to give this demo. So you can look at how iterators work. The iterator is just where I am in my linked list, or where I am currently, whatever data structure I'm looking at. And the point of it is that you can hide the fact that how things are built. I don't need to know that there's a linked list node. I can just use this data structure, find the particular position. And the reason you want to know about this is because all of the standard template library stuff all has iterators. They have iterators so that you do not know how the list class works, or how the map class works, or how name one of the data structures in the standard template libraries. They're all generic, abstract. You have no idea how things are built. You just use it. It's a tool for you to use. Iterators allow you to do that. So you can look at this code. This is brand new code, L14 LL iterator W21 for winter 21. You can look at this code. It's in the shared code repository that we have for the class, and you can see how I'm building up an iterator. Okay? And again, notice that the whole point of this is I don't need to know how things are built. I can just use the tool if I make it abstract enough. All right. So with that being said, I'm going to stop, and thank you very much for listening, guys.